Here's the question here. So it's got all the instructions here in the diagram. So let me scroll down for the instructions themselves here. And then the question's in 4 parts. So here's the actual question then, A, B, C, D. There. So I've got the summary here of the question. Let's have a look at it then. Part A. Let's look at this part first, shall we? So scroll down and just do part A. So A. It's an elaborate picture, but we don't really need it. Well, we do need it at one point, I think. So this, first of all then, this as this. So here, let's have a look at it. 24 sine theta plus 7 cosine theta. Let that equal this. That'll be r cos cos plus r lots of sine sine, isn't it? So let's equate sines and cosines then. So what have we got? Sine theta is here, so r sine alpha then. 24 lots of those. And how many cosines? Well, r cos alpha is equal to the 7 lots of cos thetas, isn't it? So that implies what r is equal to then. If we let's get r squared, this squared plus that squared, the sine squared plus cos squared is 1. 24 squared plus 7 squared. We know it's a 7, 24, 25 triangle, isn't it? So r square root both sides is 25. So there's r. Let's get tan alpha as well then and get alpha. Sine over cosine, the r's will cancel, will be 24 over 7. So alpha then shift tan that. So shift tan 24 divided by 7 in degrees mode, 73.74 to 2 dp. 73.74 degrees. And that was to 2 decimal places, as the question asked. So that was part A. Let's have a look at part B then. Find the minimum value of V. Well, here's V then. So V is equal to 21 over this thing here, which we've just written down as 25 cosine theta minus alpha. Will be less than or equal to. Now, when cosine this is 1, well, V will be minimum, because we want the minimum, don't we? When the denominator is biggest. When the denominator is biggest, this will be smallest. When is this biggest? Well, this will be biggest when this is the biggest value possible. So when is cosine 1? Because it can go up to 1, it would be 1 when theta equals alpha, because cosine 0 is 1. So theta would need to equal 73.74, and that's in the range of theta, isn't it? So that would be less than or equal to 21 over 25. So V equals 21 over 25 min when theta is equal to 73.74 degrees. And that's V min, which is what we've got. So we found the minimum value of V. Given that this is Kate's speed, find AB. So let's go back up to our diagram then. We've got a triangle here. I've put in H for the longest side. I've put this as the opposite. And we put the angle in as 73.74. So we can work out H, can't we, using the SOHCAHTOA. So sine is opposite over hypotenuse. So this is part C. So here, the sine of the theta then is equal to the opposite, which was 7, over the hypotenuse, which was AB. So AB then is equal to 7 over sine theta, which was 73.74. Which we have in the calculator, don't we? Oh no, we have that. So if we press sine of that, of the answer, equals, And then we divide it by 7 divided by that. So 7 divided by bracket. Answer, wasn't it? That's it. We get 175 over 24 meters. And we could write down the decimal to that if we wanted. So it's 7.29 meters, and that was to 2 decimal places. Okay, there's part C done then. Now we've done it. Given that Kate's speed is 1.68 meters per second, find theta, where theta varies from 0 to 150. So part D, V, which equals 21 over 25, cosine theta minus alpha is equal to 1.68. Okay, so now let's work out, we know what alpha is, and we need to find theta. So let's move this up. Cosine theta minus alpha then is equal to 21, leave that as is, and the 25. And move the 1.68 from times down to divide. Okay, so we've got that. Let's have a look here then. Let's draw our circle. CAST. Cosine is positive, isn't it? Here and here. So let's draw our 2 lines. Mark off the associated acute angle, which we'll call alpha dash then, in this case, because we've already got alpha used. So cosine of theta minus, no, let me just do that again. So here, cosine alpha dashed, the associated acute angle, is equal to this. So that tells us what alpha dashed is, isn't it? Let's type it in. So shift cos of 21 divided by bracket 25 times 1.68, close bracket, close the shift cos bracket, equals 60 degrees. So the alpha is 60 degrees then, here or here. So what have we got then? Well, we've got our angle, which is theta minus alpha then, 73.74, is equal to, the first solution will be 60, or it looks like minus 60 because this will be a plus to bring it in the range. So I'm going to try minus 60 here to see if that's suitable for the range value, and we'll do minus 60. It's going to be because when this moves over it turns into the inside the range, doesn't it? So minus 60 is the right choice there, rather than say go around to 300, and that would be outside the range. So here theta is equal to 133.74 degrees there, or theta is equal to 13.74 degrees.